Welcome to the deep dive. Today we're putting on our analytical thinking caps and diving straight into what it really takes to become a data analysis specialist, looking ahead to 2025.
Sounds good.
We've got a fascinating mix of sources here, a career guide, a social media plan aimed at aspiring analysts, and even a beginner's handbook.
Quite the collection.
Yeah, and our mission today is to pull out the absolutely crucial steps, the skills, the insights you need to, navigate this career path. It's really in demand.
Hugely in demand. And that potential is something all our sources seem to agree on. It's a promising field, for sure.
And the fact we're even looking at a social media strategy, it kind of suggests how dynamic this all is, right?
It really does. It's not just about crunching numbers in a dark room. It's about understanding, communicating, telling that story that data holds.
Okay, let's unpack this then. Step one on this path. It seems to be about laying the foundation, educator-wise. What are we seeing there?
Well, across the board, a bachelor's degree comes up frequently, often in fields like data science, obviously, but also math, computer science, finance, economics. These give you that solid theoretical grounding.
Those core analytical skills.
Exactly. They equip you to tackle, complex data challenges.
But what if someone didn't go that traditional route? Is it a closed door?
Not necessarily, no. Well, yeah, a master's degree can definitely open doors to more specialized roles, maybe higher pay. The sources also make it clear that people do break in through things like certifications, and crucially, building a really strong portfolio that shows what you can do.
Okay, so practical skills demonstrated.
Precisely. It's good news for you, the listener. There isn't just one single prescribed path. Multiple ways in.
That's definitely encouraging. So, okay, foundation laid. Next up is building that toolkit, the actual skills. And it looks like we can split these maybe, technical and soft skills.
Yeah, that's a good way to think about it. On the technical side, SQL, it just keeps coming up as fundamental, like the absolute bedrock.
For talking to databases.
Exactly. Getting the data, manipulating it. Then you've got programming. Python or R are the big ones.
Python seems really popular.
It is. Incredibly versatile. And the libraries, it has pandas, NumPy, they make handling complex data so much more manageable than it used to be. Really lowers the barrier.
Right.
R is also really important, especially if you're leaning more towards heavy-duty statistical analysis.
So it's not just button pushing with these tools. You need the underlying concepts.
Oh, absolutely. That's where understanding stats and math comes in. You need to grasp probability, hypothesis testing.
Hypothesis testing. Like proving or disproving an idea with data.
Kind of, yeah. Like being a detective. You have a theory, the null hypothesis, and you hunt for evidence in the data to see if it holds up. Regression analysis, too. It's all vital for accurate interpretation.
And then showing your work, I guess.
Yes. Data visualization. Tools like Tableau, Power BI, they're key for making those dashboards and reports that actually, mean something to people.
Can't forget getting the data ready in the first place, I imagine.
Ugh. Data wrangling. Yeah. It's often the least glamorous part, but it's so important. Cleaning raw data, getting it usable. And honestly, even good old Excel still has its place for basic cleaning and quick looks.
Right, makes sense. Garbage in, garbage out, as they say.
Pretty much.
And it's not just the tech stuff, is it? These soft skills seem just as vital.
They really are.
Yeah.
You can be a technical wizard, but if you can't communicate, it falls flat. You absolutely need to translate complex findings into clear, actionable insights, especially for people who aren't data experts themselves.
Data storytelling, they call it sometimes.
Exactly that. Building a narrative around the data. And critical thinking, problem solving. You're not just reporting numbers. You're meant to be figuring out solutions based on the data.
And attention to detail. I mean, that feels like a given, right? One wrong decimal point.
Non-negotiable. Absolutely critical for accuracy. Errors can lead to really bad decisions. Then there's domain knowledge, understanding the business or the industry you're in. It gives context. And finally, collaboration. Data analysis is usually a team sport. You need to work well with others, often across different departments.
Okay, so we've got the theory, the skills. But how do you get that practical, hands-on experience? That seems key.
It's absolutely pivotal. And the sources give some good, actionable ideas. Working on projects using public data sets is a big one.
Like from Kaggle?
Yeah, Kaggle, the UCI machine learning repository, tons of data out there. You could try things like customer segmentation, maybe forecasting sales, something real world.
And internships, entry-level jobs.
Definitely. Nothing beats real on-the-job experience in a professional setting if you can get it.
And showing off what you've learned.
Crucial.
Yeah.
Build a portfolio. Use platforms like GitHub to showcase your projects. Let employers see what you can actually do.
What about competitions?
Data science competitions, yeah. They're great for testing your skills against others, learning new techniques, maybe even getting noticed. And even online simulations or case studies can give you valuable practice.
Now, certifications came up. Optional, but maybe good. When do they add real value?
Well, they can be a good way to formally validate your skills. Show an employer, look, I've been certified in this. It adds credibility.
Any specific ones mentioned?
Yeah, the Google Data Analytics Professional Certificate came up. Also, the Microsoft Certified Data Analyst Associate. Those seem pretty popular and well-regarded. The Certified Analytics Professional, or CAP, was another one mentioned as valuable.
All right. Foundations, skills, experience, maybe a cert. What's next? Getting the actual job.
Landing that first role.
Yeah.
Look for titles like Data Analyst, Junior Data Analyst, maybe Data Analysis Specialist.
And tailor that resume, I assume?
Oh, absolutely critical. Highlight the specific skills and projects from your portfolio that match what that job is asking for. No generic applications.
And getting the job isn't the end, right? It's a career path. Where does it lead?
Definitely not the end. With experience, you can move up to Senior Data Analyst, maybe Analytics Manager, or specialize.
Specialize how?
Like focusing on finance or healthcare or marketing or product analytics. Lots of options. Some people also transition into more advanced roles like data scientist or data engineer.
It sounds like you need to keep learning, though.
Constantly. That's a huge theme. The tools change, the techniques evolve. Continuous learning and upskilling are absolutely necessary to stay relevant.
Okay, let's dig a bit deeper into some of those core tools. Python. You said it's super popular. Why is that?
Several reasons, really. Its libraries are just fantastic. Pandas makes data wrangling so much easier. NumPy is essential for numerical stuff. Matplotlib and Seaborn are great for plotting and visualization. And scikit-learn, that's huge for machine learning tasks.
So it covers a lot of bases.
It really does. Plus, it's generally considered quite readable. The syntax isn't too obscure, which helps with learning and collaboration. And the community support is enormous. If you're stuck, chances are someone has asked that question before.
And its use goes beyond just analysis.
Yeah, into AI, machine learning development. It's a very versatile, future-proof kind of skill.
And SQL. We keep coming back to it. Indispensable, you said.
Absolutely. It's the language of relational databases. If you want to get data out of most company databases, you need SQL. It's efficient, it's accurate for getting exactly what you need, it's flexible, it scales, and basically everyone uses it. It's the standard.
So knowing SQL is like knowing the basic grammar of data retrieval.
That's a great way to put it, yeah.
What about R, JavaScript, Scala? Where do they fit in the picture?
R is really strong for pure statistical analysis, academic research, complex stats modeling. JavaScript pops up more for interactive visualizations on the web, maybe handling real-time data in web apps.
Okay.
And Scala. You tend to see that more in the big data world, often with Apache Spark, for processing really massive data sets across many machines.
Gotcha. And those Python libraries, you mentioned Pandas, NumPy, what do they do exactly?
Okay, so Pandas gives you these structures, mainly the data frame, which is like a superpowered spreadsheet in your code. Makes cleaning, filtering, merging, reshaping data much, much easier. NumPy is the foundation for numerical work. Fast arrays, matrix operations. Lots of math and science libraries build on top of it.
And for visuals?
Matplotlib is the workhorse for creating all sorts of plots. Seaborn builds on Matplotlib and makes creating common statistical plots, often more aesthetically pleasing ones, simpler.
So if I'm summarizing, R for deep stats, Python for the all-around data science toolkit, SQL to get the data.
Pretty much, yeah. That's a good overview.
And JavaScript for web interaction, Scala for huge data sets.
You got it. More specialized use cases generally.
And SQL's longevity. It's just because it works so well.
Fundamentally, yes. It's efficient, accurate, flexible, scalable. You can automate tasks with it, and it's just so widely adopted. It solves a core problem really effectively.
Interesting. Now, you mentioned VBA earlier, Visual Basic for applications. In like naval shipyards. That sounds incredibly specific.
It is, yeah.
Yeah.
It highlights how data skills can be needed in very niche areas, in environments where Excel is deeply embedded, maybe interacting with older systems.
Like legacy systems.
Exactly. VBA lets you automate complex tasks within Excel, pulling data from specific systems, maybe like those naval ones mentioned, AM or NMD, cleaning it up, generating reports automatically.
And they mentioned needing specific system knowledge, too. And security clearance.
Yeah, familiarity with those specific naval maintenance systems, plus needing a DoD secret clearance. It just shows that sometimes data analyst means bringing specific domain knowledge and data skills together, even including older tools like VBA if the environment demands it.
Fascinating. Really shows the breadth. Okay, for someone starting out wanting project ideas, what would you suggest? What sounds, I don't know, doable but useful?
Well, finding something you're actually interested in helps.
Hmm.
But common suggestions are things like try web scraping some data, maybe sports stats or product prices. Take a public data set like city bike rentals or something and just explore it. Visualize patterns, that's exploratory data analysis.
Hmm.
Practice SQL by querying a real database, even a small sample one. Try a customer segmentation project. Build a simple predictive model, maybe predicting house prices based on features. Or even analyze text sentiment from reviews or tweets.
Lots of possibilities.
Yeah, the key is just to start doing something, applying the skills.
And resources for learning. Where should people look?
Loads of great online platforms. LinkedIn Learning, ADX, Coursera, FreeCodeCamp. They all have solid data analysis courses and paths.
Specific course recommendations came up.
Yeah, the sources mentioned to become a data analyst on LinkedIn Learning and data analysis for management on ADX as good examples. But there are many others too.
Let's loop back to the degree thing. So helpful, often expected, but not the only way.
That's the picture, yeah. A relevant bachelor's is definitely a common starting point and often expected by employers. But strong practical skills, proven through a portfolio and maybe certifications, can get your foot in the door.
So focus on demonstrating ability.
Exactly. And that commitment to continuous learning is vital, degree or not. The field moves too fast to stand still.
Okay, quick recap of the main tool categories then.
Sure. You've got data manipulation analysis. Think Excel, SQL, Python R, data visualization, Tableau, Power BI, Python libraries, stats and machine learning tools, things like scikit-learn and Python. And then database big data tools, MySQL, maybe Spark or Hadoop if you're dealing with huge scale.
And analysis itself isn't just one thing, right? Different types.
Correct. There's descriptive what happened, diagnostic why did it happen, predictive what might happen, and prescriptive what should we do about it. Each serves a different purpose for a business.
And underpinning all of that is statistics.
Absolutely fundamental. You can't interpret data correctly or make sound decisions without understanding statistical principles. It prevents you from jumping to wrong conclusions.
Right. And those certifications, again, good for learning, good for proving skills.
Yep. Structured learning plus that industry-recognized validation can definitely give you an edge.
And finally, those really specialized roles, like the naval one, they layer on extra requirements.
Exactly. Specific tech like VBA, yes, but also things like experience with Agile or Scrum, understanding different software development approaches like Waterfall or DevOps, knowing specific systems like AIM or NMD, and potentially needing that security clearance.
Yeah.
It's a whole other level of specialization.
Wow. Okay, well, this has been quite the journey through the world of data analysis in 2025. From education, skills, both tech and soft, getting experience, specializing, it's a lot.
It's a multifaceted field.
But clearly high demand, and it sounds like it could be really rewarding if you put the work in.
I think that's right. The sources really paint a picture of needing that blend. Theory, practice, and importantly, that commitment to always be learning. The opportunities are definitely there for people who prepare properly.
Absolutely. So thinking about everything we've covered, the tools, the skills, the different paths, what specific bit of this data analysis world, maybe it's Python and machine learning, or maybe it's diving into a specific industry like healthcare, or even that specialized naval stuff, what sparks your curiosity the most now? Something to dig into further.
Interesting question to ponder.
We hope this deep dive has given you a solid map, a good starting point. Now it's really about exploring those areas that caught your attention. Thanks for joining us on the deep dive.